All right, let's go ahead and get started. Um, so my name is David Knight. I'm the HyTech Racing President. Welcome to the Fall 2020 info session. So this is our team. We are HyTech Racing. This is a picture from Formula Hybrid from 2 years ago. Our HTO4 car is shown there. Sadly, our competition was canceled, our most recent competition, so this is from 2 years ago. We're currently in the process of building HTO5, which is this year's competition car. So an overview of the info session, we'll be talking about our team and the competitions that we attend. Then Leo, our chief engineer, will give an overview of the electrical and mechanical subteams of our team and of the car. And then we will end with our plans for fall of 2020, the unique semester that we have ahead of us, and a Q&A session with break-off rooms, one mechanical, one electrical, and one for business and project management. So about HyTech Racing, we are a fully student-led electric racing team. So we build formula-style electric race cars, and we build a new one every year. So we start from the ground up, excuse me, and build a new race car each year. So the competitions are in the summer, and we compete against other schools around the country and some international schools as well. So HyTech Racing is a club where we solve real world engineering problems, and not only engineering problems, but also business and project management. It's really like a real introduction to the way that a team operates, an engineering team operates in the real world. It's multidisciplinary, so we have engineering, all the different engineering majors. We have some science majors, business majors, industrial engineering. It's really a multidisciplinary team where you're going to be applying skills that from your major and from other majors and picking up on things from basically everything that's required to make this team operate. So an additional bonus of joining the team is companies. Really, FSAE has a big name to a lot of companies. It's a very established organization that is well known in engineering companies. So they generally hire from FSAE teams before they hire from the general population of campus. So the Formula SAE competition, we compete in the electric version. There's an internal combustion version and electric version. So it's in June every year. It's scheduled for June 2021. As I mentioned before, in June 2020, it was canceled because of the COVID situation. But the way that our competition works is we have static events and dynamic events. So our static events are passing inspection, going to a design presentation, a project management presentation, and a cost presentation. So these are more of the showing the work that you've done, not necessarily judging how good your car is. And then the dynamic events are basically just showing how fast your car is, how quick of a car you've built. So there's an acceleration event, skid pad event, autocross, which is like a short, like minute to 2 minute kind of race, and then an endurance event, which is a 22-kilometer endurance run. So testing both your speed and your longevity. And then there's an efficiency metric, which is also taken into account in the final score. So you have to pass technical inspections and some other like technical requirements to be able to race. And then you can compete in the dynamic events. So I mentioned that Formula Hybrid is the competition that we went to previously. We came in first place in 2018 and 2019, and then decided that in 2020 we would try our hand at FSAE, which is a larger competition. Unfortunately, we were not able to compete there, but we like to think that we would have done very well. We're the second team in Formula Hybrid history to finish the 44-kilometer endurance race. So FSAE has a 22-kilometer endurance race. Formula Hybrid has a 44-kilometer endurance race. Our team structure, so as I mentioned before, there are a lot of different parts of the team, and we need to keep them relatively organized in order to do the work that we do and produce a car at the end of the day. So it starts off with project management. This is the president, chief engineer, and the project management leads who are really overseeing the entire operation, making sure that all of the parts are working together. We have business, mechanical, and electrical, and communication between those is not always easy. It's definitely not trivial. So project management helps facilitate that. Business, very similar to project management and making everything work. So this is handling our financial operations, outreach, and sponsors, and then design and branding. And then mechanical and electrical, we have sub-teams broken down underneath this. So for mechanical, there's aerodynamics, chassis, controls, composites, powertrain, and suspension. And then under electrical, there's electric drives, data acquisition, high voltage and low voltage controls. So we'll get into all of these sub-teams and more of what they do. So I'm going to hand it off to Leo, the chief engineer, who will be talking about the electrical team.
All right, hello everyone. My name is Leo. As David said, I'm the chief engineer for HyTech Racing, and I'll just quickly walk you through the different engineering sub-teams that we have on our team to give you a little bit of an idea of what exactly we do and what you would be doing if you joined our team. So our electrical team has 4 major sub-teams: electric drives, data acquisition, high voltage controls, and low voltage controls. And we'll start it off with electric drives. Next slide, please. Okay. Electric drives, the leads for this sub-team are Anson and Dean. So the main activities of the sub-team are the following. They're responsible for delivering electrical power to the vehicle's motor. So basically, they have to produce our 300-volt battery pack and ensure that the energy from the battery pack goes to the motor and powers the car so we actually can race it. So they designed the 300-volt battery pack from ground up, but they're also responsible for ensuring that all the components that deliver this power to the motor are cooled properly, so the motor controller, and the battery. And also they do motor research and understanding of the performance of the motor, understanding how we can utilize our motor better and how we maybe can switch to a better motor in the future. Some of the goals for this year for the sub-team are explore new methods of segment and full battery cycle testing. So we currently do a lot of individual cell testing, but we're also looking to improve our testing procedures to allow us to test the full battery pack. We're also developing a system for thermal battery characterization. So understanding how the battery performs under different kinds of loads and how to cool it better. And we're also working on optimizing the architecture for our next vehicle on HTO6 to improve the overall weight of the battery pack as well as optimize cooling. This is a picture of a battery segment from HTO4, our vehicle from 2019. So this is a 1/4 of our battery, and it's 18 cells connected together in series. And then these segments are connected in series together to produce a 300-volt battery pack. And this is just a picture of the internals of our battery when the segments are inside, and you can see those four blocks are the battery segments from the picture earlier. So moving on to data acquisition, the lead for data acquisition is a tool, and the primary responsibilities for the sub-team are collecting and logging data on the car. There's a lot of data from different subsystems of the car and different sensors that need to be collected and saved and for further analysis. They're also responsible for ensuring that the data can be streamed wirelessly from the cars and can be accessed by engineers on the side of the track to understand the performance of the car and maybe inform driver about what's going on with the car. And also they perform a lot of data analysis because, as I said earlier, there's a lot of data that we collect on the car, and it's important to understand this data and what to do with it and how we can improve the car using that data. And they do a lot of sensor integration to provide different subsystems of the car a way to collect information on their parts, their systems, and maybe help design those parts in the future better or validate their assumptions and simulations that they've done during the design phase. And the goals for the year, we're looking to incorporate more sensors to collect data on suspension, specifically working on strain gauges and also looking into linear potentiometers. So that will allow us to verify a lot of the simulations that we've done in previous years on our suspension design and potentially improve for future vehicles. We're also working on continuing improving the live data visualization. You can see here on the right is a picture of a dashboard from our current solution, and we're just working on improving the latency of the system and the robustness of it. And we're also trying to develop better post-race analysis tools so that we can include potentially video overlays and we can where we can record what driver sees during the race and then overlay sensor information on top of the video so that we can see what happens in each specific corner and how we can improve the car and maybe drive it better and things like that. Next slide, please. Okay, moving on to high voltage controls. Lead for high voltage is Arvind, and this subsystem is responsible for the design of high voltage electronics. So there are a lot of electronics that are required to actually manage our high voltage battery pack, and it's a complicated task to design electronics that can withstand 300 volts. So this subsystem specializes in this and makes sure that we can monitor our battery. So this is the battery management system. So they develop both the hardware and software. Here in the picture, you can see this green circuit board is a part of the battery management system. So it actually monitors the health of all the battery cells in the battery pack. And then also they're responsible for designing the safety circuitry for our battery pack to ensure that if something goes wrong, the car can be safely shut off and everyone can be informed through various signals that there was an error and where that error happened. Moving on to the goals for high voltage controls for this year. Next slide, please.
I think we're having some technical difficulties here. It's showing the next slide on my screen, but I'm not sure what's going on with that.
Yeah, I can see the slide with the goals on it. So if you just keep talking, Leo, I think it's fine.
Okay, sure. So the goals for the high voltage sub team this year to finish the manufacturing of some of the components for the battery management system, and for the current vehicle, as David mentioned earlier, we had to finish our year early. So there's still a few things that we need to finish with the battery management system. We're also looking to improve the robustness of the safety circuitry to ensure that in any scenario the vehicle can be shut off safely. And also working on implementing a system where our low voltage electronics can be powered from the battery pack, effectively removing the smaller low voltage battery and minimizing the overall weight of the vehicle.
Okay, I'm gonna continue with the presentation. I think we're having some technical issues, so I'm just gonna continue where Leo left off here. So this is some more views of the electronic systems. This is the HV board, which also aids in computing some of the data that the HV board, the battery management system, produces. So low voltage controls, the lead for this is Ethan. So the main activities that they do are design of the main ECU. So this is basically the brain of the car. Computes lots of sensor data and safety mechanisms and circuitry to ensure that everything is running smoothly. And then also interfaces between the driver controls, so pedal inputs, and the motor controller. So basically converting the data into usable form for the motor controller. And then another thing they do is wiring harness design and construction, which is basically all of the wires that are communicating through the car are bundled into one wiring harness. So the goals for the year are to finish manufacturing the main ECU, and then to develop some additional testing material for the boards. So that's developing standard PCB testing procedures throughout the entire team, not just for their sub-team, and then reducing noise in developing the testing procedures that they're developing. So this is a picture of the main ECU, which is fully designed in-house by HyTech Racing. And then here's a picture of the wiring harness. Okay, so next we're going to talk about the mechanical subsystems, which consist of aerodynamics, chassis, controls, composites, powertrain, and suspension. So the suspension leads are Daniel and Mark. So suspension is obviously responsible for the construction of the suspension of the car. So this is a lot of like mechanical analysis of all of these components. So doing a lot of CAD, obviously, and then finite element analysis, which for those that don't know is basically a way of characterizing the loads on an arbitrary shaped object. So it's very helpful in determining stresses and basically the strength of your system. Topology optimization is very similar to FEA, but it basically just tells you where you can remove material to make something lighter. And then performance simulations on the suspension in the car as a whole to ensure that our car is as good as we design it to be. So some of the goals for suspension this year are developing an understanding of vehicle dynamics. This is very important, obviously, designing a vehicle, and it's something that's very difficult to understand. So we're putting a lot of effort into figuring out how our vehicle acts under all of the loads that it experiences and how to make it faster. And then doing more simulations. So this is also involved with vehicle dynamics, applying the understanding that we gain in different simulation tools to make the car faster. So powertrain is basically the assembly that you see in front of you. It's the motor and the differential and then a gear reduction. And this basically just is the interface between electric drives, which is the battery pack, and the suspension. So it converts the energy from the battery pack into a usable form for the wheels. So some of the activities that we've done in the past are developing the powertrain architecture. So everything is obviously we try to reduce the mass of everything as much as we possibly can. So this uses a lot of FEA and topology optimization as well. And then gear ratio optimization. So we have a motor and we know all the characteristics about the motor, and then we want to get all of this power to the wheels in the most efficient way that we can. So there's a lot of analysis that goes into that. So the goals for powertrain this year obviously are to complete the powertrain for HTO5, and then develop testing procedures for a dyno. So a dynamometer is a way of characterizing your motor, figuring out the power relationship and torque and a lot of things like that. And then to explore future powertrain architectures. So we have a one motor architecture, but there are many different ways that you can organize your motors for an electric vehicle. You're not really as limited as an IC vehicle where you have one engine. We can really have as many motors as we want and put them at wherever we want to. So investigating that is a big engineering design problem. Controls is led by Kevin. So the main job of controls is to make the driver as comfortable as they can be, and as confident as they can be. So this is like everything needs to be very ergonomic so that you're comfortable, and then the confidence comes with tuning and adjusting the driver and the car to the driver to ensure that they're able to push the car as fast as it can. Driving a race car is not a simple task, and it's something that's very difficult actually. So controls is very important to ensure that the driver is as confident as they can be. So some of the goals for the year are to improve the ergonomics of the current design, and also to improve them in a way that doesn't negatively impact other aspects of the car. So you can make the driver comfortable, but you also want to lower the center of gravity, for example. So this comes with the development of an ergonomics jig. So this is basically a box that we build outside of the car to test certain things, make sure that the driver is comfortable. And then we're going to be exploring different designs of the pedal box and improving the rigidity and robustness of steering elements. This goes a lot into the confidence of the driver as well, and the feedback that the driver gets. So chassis is led by Aaron. Main activities are obviously to design and construct the chassis, but the chassis really has to interact with all parts of the car because everything is mounted to it. So there's a lot of considerations with how things are going to be packaged relative to other subsystems, for example. So ensuring that everything is really low for a low center of gravity, and then optimizing for weight and stiffness. So low weight, high stiffness. So some of the goals for chassis, increase the chassis stiffness while also reducing weight. This comes through applying design principles to FEA and better understanding how our chassis reacts to the loads that we put through it. Developing strain measurement procedures. So this goes into the data acquisition of strain gauges, figuring out if we're actually characterizing our loads properly, and if we're not, then we can change our design. And then also vehicle dynamics. It's always a really big one. Understanding vehicle dynamics is critical to developing a proper chassis. Aerodynamics is led by Mike and Federico. So they design and construct all of the aerodynamic elements of the car. So this is the nose cone, the front wing and the rear wing, and then side pods. So they do a lot of simulation, a lot of theory as well about how to optimize an aerodynamic system, and then also integration with the aerodynamics to the vehicle dynamics to ensure that we have a properly balanced car with the aerodynamic forces that we're adding to it. So the goal is to finish manufacturing the aero package. So HTO4 actually did not have an aerodynamic kit as far as the front and rear wing goes. So HTO5 is new to us in the fact that we are taking on this design challenge, and it's the first time that we've done it as a team. So this is going to be an iterative process, obviously, as all engineering problems are, and it'll be supported through extensive vehicle testing. Composites works very closely with aerodynamics. So all the aerodynamic structures are actually made out of carbon fiber or other composite materials. So the composites lead is Kaushal, and composites in general just does a lot of manufacturing for other sub-teams and like aiding in the design considerations for those sub-teams. So developing bodywork, wings, utility panels for electrical teams, other generally flat panels. We try to use composites material because it's very light and stiff. They do a lot of mold making. So the picture that you see there is the creation of the seat or the mold for the seat, which is laid up using carbon fiber. So their goal is obviously to finish manufacturing the composites for HTO5, and then really to increase our understanding of the process of using composites and how to model them as well in finite element analysis. It's a big problem with composites because they're not they vary with the grain, so it's hard to model them in finite element analysis. But it is possible, and if it's something that we're able to really master, then we can make some really complex and interesting parts out of composites. So that's it for mechanical, and now I'm going to talk about business and project management briefly. So business obviously is dealing with all of the financial side of our team. So we manage a budget that's about $70,000 or more, depending on the year. So the business team is really responsible for gaining and retaining sponsors that give us all of this money, and negotiating with SGA to ensure that we actually get a larger budget or a large enough budget for us to operate as a team. And then they also do a lot of design and team branding. So all of the social media posts and everything that you've been seeing, especially through the recruitment business, has been very busy. So the goals for business are to improve how we interact with our sponsors. So ensuring that we're delivering on the promises that we've made them, keeping track of which sponsors we want to reach out to, and then actually going and reaching out to them. So securing sponsors for fiscal year 21, and then develop unified team branding. So the way that we portray ourselves out to the world, we want to have a unified look, and so that when people see something, they recognize it as a HyTech racing promotional, for example. And then designing the livery for the current vehicle. So project management is led by Eric and Jayan. Project management focuses on optimizing the team, making sure that all of the parts of the team work together. So this is implementation of just project management methodology. It sounds simple, but it's actually very, very complex. Getting a team of over 100 members to properly work together is very difficult, especially with the resources that we have. So we have to be we have to use our resources very wisely in order to do this properly. So team progress tracking, we're responsible for the entire team and making sure that the car gets built at the end of the day. So making sure that everybody is doing what they need to do. Then some logistics and supply chain management as well. So the goals for project management is to continue the development of the project management system that we've implemented. COVID has given us both it's opened our eyes to a lot of problems that our previous system had, and it also gave us an opportunity to make a change. So we've taken that opportunity, and over the summer have been implementing a new project management system. So that's the goal, is to continue developing that, and then improve the documentation of everything that we've done, so that future years can understand and operate it as efficiently as we are, and then build the car. At the end of the day, it is project management's job to ensure that everybody is making progress, and at the end of the day, finishing the car. So fall 2020 is going to look very different for all of us. Everybody knows that at this point. But due to COVID, our shop access is very limited. So we are going to be prioritizing past members and working new members in. But we have to finish our car, and so doing the necessary work to get us there is going to be prioritized. So all new member meetings will be conducted virtually. Well, all meetings in general will be conducted virtually. And these will happen through Microsoft Teams. So you will be getting an email over the weekend of joining a new member team where we'll be conducting our communications and virtual meetings. So these will be happening on Tuesdays and Thursdays at 7 p.m. and Sundays at 4 p.m. for about the first month. This is kind of different from what we've previously done, but we really want to give you guys like a really good foundation of like knowledge of our systems and some more advanced engineering concepts before giving meaningful work that's going to support the team. And then after training, you'll be joining a sub-team and be working on projects remotely. And then as occupancy allows us, we'll be bringing new members into the shop. So here is the sign-in QR code. If you missed it initially, go ahead and scan that and sign in so that we know you're here. Like I mentioned earlier, the new member team invitation will be coming your way this weekend. So be looking out for that. That's how we're going to be connecting with you going forward. Our first virtual meeting will be starting Tuesday, September 1st at 7 p.m. We'll be giving another overview of our team. So this will be, and then going forward, Tuesday, Thursday, Sunday will be the schedule. So dues are $50 a semester. The first 2 weeks of meetings, of training sessions are going to be basically free. You don't have to commit to anything for that period of time. And then we're going to be setting a cutoff date sometime around the 2-week mark where you'll have to pay dues to continue going to meetings. And if this is a problem, you can always talk to us about it. We don't want this $50 dues requirement to be a restrictive part of anybody joining the team. So with that, that's basically the end of our info session. You can join the link tree there, and it will direct to 3 different Blue Jeans sessions where you'll be able to talk to the mechanical leads, electrical leads, and business or project management leads. So go ahead and join those sessions, and we will see you, I guess, over there in a couple minutes. Thank you, everybody, for joining.